Okay, y'all, if you'll get your notes out, this little quick video is going to be about section 4.1. It talks about probability. That's defined as the chance of an event occurring. Flipping a coin, drawing a card, or rolling a die are all examples of a probability experiment. The outcome is the result, and a sample space is the set of outcomes. So if we want to find the sample space of two coins flipped one at a time, we know that there's heads or tails that could happen. So we could get heads, 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 tails, tail, head, or tail, tail. Okay, the next example asks us to find the probability of 3 coins. Okay, so let me get rid of this. So this time we're flipping 3 coins, so I could get all heads. I could get head, head, tail. I could get head, tail, head. Tail, head, head. Tail, tail, tail. Tail, head, tail. Tail, tail, head. Or tail, tail, tail. Okay, if we keep on going, it says the sample spaces above were found by observation and reasoning. Another way to find all possible outcomes is by using what's called a tree diagram. So if we go to this slide and we draw a tree diagram, you're doing the same thing you did a while ago, but you're just making it look like a tree with branches. So if I flip a coin, the first time I flip it, I can get heads or tails. So these are going to look like branches. The second time I flip it, if I got a head first, I could get a head or a tail, head or tail here. The third time I flip it, I could get a head or a tail, and all these possibilities. So my outcomes, you can see them. I could get head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. All right. Okay, I think the rest of the notes, everything was filled in. If you have a question about any of that stuff, you can let me know. All right, the next thing I want us to do is to take your book. I'm going to work a couple of problems with you, just in case you're kind of still on the fence about what's up. And the first problem I want to work is number 13 on page 198. So page 198, number 13. Okay. All right. So you might want to pause the video and read it. I'm just going to kind of summarize it real quick. We have a dice. It's rolled one time. We want to find the probabilities. A says getting a 2. You know, on a dice, there's 6 sides. There's only 1 2. So the probability is 1 out of 6. Part B says getting a number greater than 6. There's nothing greater than 6, so that's 0. Letter C, getting an odd. On a dice, you know there's 1, 3, or 5. So there's 3 numbers that you could get. That reduces into a half. And D says getting an odd or even. Well, that's going to happen. That's a given. So the answer is 1. Okay, let's go to 15. 15 says, this time we're rolling 2 die, 1 at the time. Find the probability of getting these. Alright, so this time we got 2 die, and part A asked me for a sum of 9. Alright, if I'm gonna get 9, I could roll a 3 and a 6, a 6 and a 3. I could roll a 4 and a 5, a 5 and a 4. So that's 4 possibilities out of 6 outcomes times 6 outcomes, because I have 2 dice. So that reduces to 1/9. Okay, B. 15B says a sum of 7 or 11. So these are the ways to get 7. 6 and 1, 1 and 6. 5 and 2, 2 and 5. 3 and 4, 4 and 3. And the ways to get 11 are 6 and 5, 5 and 6. That's a total of 8 outcomes out of that 36, which reduces to 2 nines. Okay? Part C says doubles. Alright, you know doubles means 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So that's 6 out of 36, which is 1/6. Okay? Alright, I'm going to go to a new screen. Let's talk about 17. 17 is a big part of probability because it talks about cards. If you don't know about cards, you need to look on page 187 because it breaks them down for you. Alright, 17 part A says if one card is drawn from a deck, find the probability. Okay, 17A is a queen. There's 4 queens out of 52 cards, reduces to 1/13. 17B, a club. 13 cards out of 52 are clubs, that's a 4. 17C, a queen of clubs. There's only 1 card that is a queen of clubs, and it will not reduce, so 1/52. D, a 5 or an 8. I'm sorry, that's a 3 or an 8. There are 4 of each, so that's 8 out of 52, which reduces into 2/13. Okay, and the last one of those, letter E, a 6 or a spade. There are 4 6s. There's 13 spades, but we can't count the 6 of a spade twice. So there's actually just 16 of those. And I reduce that into 4/13. Okay, let's look at 19. 19 says, a shopping mall has set up a promotion as follows. With any mall purchase, $50 or more, if the number 1 comes up, the customer wins $10. If 2 comes up, they win $5, and if 3 or 4 come up, the customer wins a discount coupon. Find the following probabilities. Well, the spinner is on the following page, which is page 199. So take a second and look at it. A asks, the customer wins $10. If you look at the spinner, there are 2 $10 sections, which that happens when you spin a 1. There's 20 sections, so that reduces to 1/10. Okay, letter B. The customer wins money. Okay, they win money if we spin a 1 or a 2. There's 4 of those sections, so that reduces to a 5th. And C says customer wins a coupon. You win a coupon if you spin a 3 or a 4, so that's 16 out of 20, which reduces to 4/5. Okay, the last one I'm going to do with y'all in this section is 21. 21 is talking about blood. It says it's grouped into 4 types, and it gives the percentages. It says choose one American, find the probability that A this person has type O blood. We need to make that a decimal. You know, to make a percentage a decimal, you move it 2 places to the left. So that's 0.43. Has type A or B, I would add those together, make it a decimal, so that's 0.52. And 21C does not have type O or A. That means if you don't have O or A, you have B or AB, so that's 17%, which is 0.17. All right, if you got some questions about this section, just shoot me a message.